In the 21st century, planet Earth has been heating up significantly year after year. When it comes to the hottest temperature ever recorded, 2019 broke records across the globe, while 2020 shattered them. What was once a naturally occurring seasonal event is now being attributed to the increase of carbon emissions that is wearing away at the Earth's fragile atmosphere.
If we fail to act on this problem, it starts to look like some of the dystopian futures that have been portrayed by Hollywood. Post-apocalyptic, where a large part of the planet becomes unlivably hot and dry, and where you have extreme competition and conflict over diminishing food and water and space. There is a path forward where we do preserve this planet for future generations, for future human civilization. It's a matter of whether we have the willpower to tackle this problem before it does become too late.
Unless the current trends are reversed, humanity is on a collision course to make more regions of the world uninhabitable, where boiling temperatures could be the new normal. It's all due to one of the deadliest weather events ever known, the heat wave. Hot weather that can last for several days is generally known as a heat wave.
Well, a heat wave is an extended period of extreme heat, several days, typically with temperatures above a threshold like 90 degrees Fahrenheit.
Heat waves can have a significant impact on the environment, society, and human health.
Heat waves really are a silent killer, especially with the young and the elderly and the infirm, who have the least resilience when it comes to coping with high temperatures.
Now, a new report suggests that by the end of the century, heat deaths globally could nearly equal those from all infectious diseases combined.
It's called a silent killer for the reason that heat wave do not descend upon an area with a bang. They creep in slowly, impact populations over an extended period of time, and also there are no visible signs of destructions associated with heat waves, as is the case with some other natural disasters.
They are triggered by high-pressure systems that hover over an area, absorbing heat beneath it like an oven. High-pressure systems push the air down. Hot air near the ground cannot escape into the sky. Without the rising air, no clouds form, and consequently no chance of rain. The sun simply cooks a given area until some other system is strong enough to push this stagnant high-pressure system away. The longer the heat wave lingers, the deadlier it becomes for all life under its spell. This was the case in 2003, when one of the worst heat waves on record struck France and much of Europe. In a cemetery outside Paris are the graves of 57 people who some consider to be the first casualties of global climate change. Here lie the victims of the worst natural disaster in French history.
One of the first signs that we saw that climate change was really dramatically increasing the incidence of these extreme heat events, extreme heat waves, was the summer heat wave in Europe in summer 2003.
But this devastating heat wave that begins in August does not come without a warning.
In June, we had early signs that were linked to soil drought in Western Europe. Since we had a particularly dry spring, so the soil was already very dry. If there is little humidity in the soil, there is no evapotranspiration phenomenon, which would allow France to cool down.
To understand how it works, of course, it's like in summer we throw water on the terrace to make it cool. It's the opposite. If the soil is dry, it can't evaporate water and therefore cool the lower layers of the atmosphere by the latent heat. Thus the fact that it cools when it evaporates. If this phenomenon is diminished, obviously the heat wave is amplified. If there will be weather conditions for a heat wave, it will be severe. When I started to have concerns, at the time I was living in a very big suburb, and on my way home by motorbike, I would pass through some woods, and in fact, I had noticed things. Leaves were falling. Leaves were falling, I thought. That's strange. And there were tree branches cracking and falling. I said to myself, how odd.
In the early summer of 2003, plants and leaves wilt away, succumbing to a drought. There is no moisture left to evaporate, a bad omen of what is yet to come.
In 2003, we had one of the first events that made the link between drought and high temperatures so obvious. These things are very well known now, but in 2003, we didn't necessarily fully anticipate the fact that this drought in the soil was going to intensify the temperatures as much as it did.
It begins with a warm air mass that moves northeast from the Mediterranean across Spain and into France.
You had the sort of heat that you would normally expect in North Africa, in Saudi Arabia, parked over England and France. This high-pressure region that's normally centered in the subtropics had migrated all the way up into northern Europe.
The heat wave is parked over Western and Central Europe. The air mass is part of a phenomenon known as an anticyclone, a large-scale weather system bound by slow rotating winds and marked by extremely high pressure that prevents other systems from displacing or disrupting it. Since the air mass doesn't move much, the temperature begins to rise.
The anticyclonic conditions, the blockage that had settled over the European continent, was self-sustaining by the hot air that fed it, and nothing could come to change it. On the 1st of August, Météo France issued its first meteorological press release signaling the arrival of very high temperatures over France over the coming days.
Well, the temperatures in Paris on Monday have been absolutely sweltering. We've had temperatures forecast up to 35 degrees Celsius, which will feel more like 41.
Despite the warning, the heat appears primarily as an annoyance to the general public. August 1st kicks off the traditional summer vacation ritual in France. People are leaving the cities and heading toward beaches, the countryside, and mountain resorts.
It's hot, it's summer, it's holidays. We do what we want. Heat is nothing. It's a sign of happiness, etc. All wrong, all wrong, all wrong. The message didn't get through from this famous first week.
Media coverage focuses on the heat as a human interest story, the devastating consequences for the nation's farmers. Emaciated livestock, parched fields and blazing forests is what the country is watching on TV. Stifling temperatures in Paris create a boom for cafe owners and bottled water vendors. But not everyone is oblivious to the danger.
At the time, I was president of the Association of Emergency Physicians of France, and we had consultations with the ministry, and we had an appointment with the Minister of Health, Mattei, at the time. And I told him, we really have a problem with hospitalizing people from the emergency rooms. We were already saturated, and I told him, it's going to be very complicated in the summer. Why? Because the staff were taking their summer holidays. Hospitals weren't hiring staff, so we were closing beds. And we didn't hire staff. The consequence was that people were having to wait in the emergency rooms.
But how does humanity prepare for such a potentially catastrophic event? It starts with time. Scientists at the National Center for Atmospheric Research in Boulder, Colorado, are using computer simulations to develop a short-term forecast model for extreme summertime heat. They're looking back in time to see how accurately their model captured heat waves globally and in the various seasons.
We are getting better in our weather forecasts, in our ability to forecast, for example, periods of extreme persistent heat, a week out or even more. And that provides us lead time where we can notify people in advance to take the precautions necessary to deal with upcoming extreme weather events.
Today, heat waves can generally be predicted 2 weeks ahead. But the goal of the National Weather Service in the United States is to achieve a 3 to 4 week advance forecast. With time to prepare, endangered populations around the world will be able to react quickly. In India, detecting a heat wave in advance will reduce its impact and save lives.
People seek shelter wherever they can. The combination of searing temperatures and hot winds has turned much of India into a furnace.
As far as the tropical areas are concerned, where India is located, the high-resolution general circulation models are now capable of providing us quantitative and location-specific forecast of temperature, along with actionable recommendations for about a week in advance. These accurate predictions, when communicated to the communities which are going to be impacted, along with the health system preparedness, which involves not just the meteorological department, but there are many other agents involved. It helps us putting system in place that has helped the country to bring down the casualties.
Advanced warnings mean extra time to prepare your home to stay cool, to ready public cooling centers, for utilities to prepare the electric grid for the surge in power consumption from air conditioning, and to stock up on water and food supplies to avoid traveling outside. Just how does the human body cope with extreme heat? Our bodies strive to maintain a constant internal state of 98.6 degrees Fahrenheit or 37 degrees Celsius. But when the outside air is consistently higher, the body reflexively cools down.
Human body normally cools through respiration, that is cooling of sweat from the body. The sweat evaporates and which leads to cooling. But a prolonged exposure to heat can overwhelm a body. An overheated body suffers involuntary muscle spasms, muscle failures, and also widespread inflammation in the body. The dilated small blood vessels are an indication that the blood is not being returned to the heart properly. The reddening of the face and the body, they give us a signal that the muscles are not able to pump the blood back to the heart.
The first sign of hypothermia is irritation. I mean, someone who doesn't drink enough. It's people who get annoyed while driving. It's worse for people who are already sick and take drugs, which can disturb thermoregulation such as neuroleptics, particularly psychiatric patients. And of course, the elderly. We can be very hot during the day, very hot. It doesn't matter, as long as it's cool at night, your body will recover. Where it gets problematic is if it's very hot and the temperature doesn't drop at night, so your body doesn't recover.
If nighttime temperatures are too high, then you see high rates of mortality with these heat waves among, again, the elderly and the young. And it is, in essence, a silent killer. Many of these people, unfortunately, die in their sleep because of the heat stress from unprecedented levels of warmth.
In Paris, troubling signs of a disaster in slow motion accumulate. Temperatures remain abnormally high, with no let-up at night. Nearly all domestic news coverage is connected to the heat. Reports of uncontrollable wildfires, stories about excessive ozone pollution, and farmers complaining of drastic losses of livestock fill the airwaves. Stories about the homeless in Paris appear on television. City shelters are closed because of short staffing. If cooling centers are not available, the severe heat stress on children and the elderly will result in a catastrophe of human mortality in the French capital.
We got the information from our colleagues in the ambulance service that there had been about 10 cardiac arrests during the night. That's when I said to myself, something really strange is happening. The emergency wards were overflowing everywhere in Paris, in the center, etc.
On a prévenu les pouvoirs publics, mais pas de réponse.
We warned the authorities, but there was no response. Everyone was on holiday. In fact, there was no communication plan, no communication officer, nothing at all. I said to a team from TF1, "It's a disaster. We can't cope anymore." I said, "Nobody cares at all."
On August the 4th, 4 days into the 2003 heatwave, much of Europe is smouldering under the intense sun. Nowhere is it felt more acutely than in Paris, France.
We already had problems finding beds to hospitalize patients in the emergency room. The emergency room was already saturated. We were closing beds. We were saving money. We weren't hiring staff. And people were waiting in the emergency room. It was a real cataclysm. And it's a very heavy burden to carry when you're a doctor all alone.
A health worker in northwestern France reports 3 deaths due to heat stroke. 2 died with body temperatures exceeding 107 degrees Fahrenheit.
The afternoon of the 5th of August 2003 remains the hottest we have in our archives, close to 38 degrees. This record has not been broken. We were really shocked. It was completely different to what we had seen before.
As global warming increases, so does the occurrence of heat waves across the globe. Places like India and the US are seeing more of their share of this deadly weather event.
We now have systematic records of heat-related casualties for about 30 years now. And during that period, the year 1998 experienced the deadliest of the heat waves when 3,058 people died directly because of the heat wave impacts.
In the 2015 heat wave in New Delhi, temperatures are hot enough to melt pavement in the capital city.
The year 2015 comes second behind 1998, when the heat-related deaths across the country stood at 2014. After that, we have put a system in place involving the meteorological department, the health agencies, and other stakeholders, which has helped bring down the heat-related casualties across the country.
In May 2019, a deadly heat wave sends temperatures above 120 degrees Fahrenheit in northern India. But now, Indian authorities are armed with preventive measures, like warnings to the public not to go outside after 11 a.m., or pouring water on roads to keep them from melting. The death toll for that summer's heat wave is limited to 373.
Highest temperature ever on Earth, with mercury levels rising to 54.4 degrees Celsius on Sunday afternoon.
We witnessed the hottest temperature ever recorded on this planet, ever recorded reliably on this planet, 130 degrees Fahrenheit in Death Valley, California.
In this case, we recommend that you obviously make sure that you're staying away from the sun and limit your outdoor activity to the late evening, right, when things tend to cool down.
And that was at a time when, in fact, all of California was seeing extreme heat with temperatures at 120 degrees Fahrenheit in Los Angeles.
A recent US government report confirmed that the years from 2010 to 2019 were the hottest decade since record-keeping began 140 years ago. And 2020 is the warmest year on record globally. Unless nations of the world take dramatic action soon, a warming of at least 5.4 degrees Fahrenheit, 3 degrees Celsius, is expected by the end of the century, making the Earth roughly as warm as it was in prehistoric times, 3 million years ago, long before Homo sapiens appeared. Human beings have never lived on a planet as hot as the Earth is today. A 5.4 degrees Fahrenheit warmer world would be radically different from the one we know now. Rising seas could swamp cities, epic droughts will turn rainforests into deserts. The increased heat alone would kill significant numbers of people. The result is clear. The warmer the world becomes, the more people will die. Back in France, the French television network TF1 reports on a catastrophe in the making. High temperatures melt electric lines and swell train tracks, stranding thousands of passengers in overheated train cars during one of the country's busiest travel periods.
People were dying. We didn't have enough equipment. Things were not going well at all in hospitals. When you're surrounded by dead bodies, it's really very demoralizing. And we had to comfort the nurses who often cried. Our morale was very low, but we kept going in order to save as many lives as possible. We realized that we are facing an event that has never been seen before. The weather models already predicted that we were going to beat the absolute temperature records, and the feeling was one of incredulity, the impression of experiencing something quite incredible.
While French health authorities raise concern that the country might experience hundreds of excess deaths linked to the heat, French media fails to take any interest. At the time, national health authorities have no idea that 6,500 people had already died from the heat's effects. Many are elderly, found in their apartments, nursing homes, or homeless on the street.
Les températures vont avoir le même niveau.
The temperatures remained at the same level from the 2nd of August. If there was a change in the air mass, it didn't affect the temperatures. There was a press release that was issued on 8th of August to emphasize the exceptional temperature level and the worrying consequences for human health.
Donc le 8 août 2003,
on the 8th of August 2003, the meteorologists from Météo France clearly identified that these extreme temperatures posed a health problem.
Even hospitals struggled to stay cool.
The hospital fire brigade tried to water the facades, totally useless. They were spraying the walls with masses of water and reduced the temperature by only half a degree the whole time they were doing it. The rooms that were most comfortable were, in fact, the hospital car parks, which were underground, where there were a few droughts and where it was cooler.
In cities, buildings, roads, and infrastructure can be heated to 50 to 90 degrees hotter than the air, while natural surfaces remain closer to air temperatures. Concrete and tarmac soak up heat from the sun, warming the spaces around them and keeping temperatures high even after the sun has set.
The phenomenon of the urban heat island really emerged during the heatwave of 2003. The urban heat island is the fact that it is warmer in the urban area than in the surrounding rural area. This is often compared to a form of heat bubble that is found above the urban environment.
We have asphalt, and this absorbs a lot of electromagnetic heat from the sun's radiation, and it traps it within the urban environment. And so that makes the air around an urban environment hotter than it would be in a more natural system.
At night, the temperature stored in the concrete surfaces, which are often quite dark, will remain present in the city. The human body, in order to function properly, needs to be able to cool down during the night. This urban heat island can go up to 10 degrees in periods of summer, of heat wave.
Heat islands have become increasingly significant, as close to 70% of the world's population is expected to live in cities by 2050, exposing their inhabitants to extreme temperatures.
If you live in any number of large cities around the world, you have both the large-scale warming effect of global warming, but on top of that, you have this urban heat island effect. And that means that urban localities, and often our urban regions are where we have the largest population of poor people, people who don't have the sort of access to air conditioning. They don't have the resilience that other people do, and so there is sort of an issue of climate justice here. Those who contribute at least to the problem are likely to bear the worst impacts of climate change.
Climate justice is the recognition that some people are going to be more vulnerable to the impacts of climate change than others. Climate change is as much a social problem right now as it is an environmental problem. And we can address both racism and climate at the same time and hopefully uplift all individuals.
We need to be thinking also about ways of mitigating those impacts in urban regions. And there are things that we can do, green spaces.
The shade cast by trees helps to alleviate some of the absorption of heat by roads and paved areas. In addition, the trees release tiny amounts of water vapor from their leaves, which helps cool the air around them.
One potential solution for addressing some of these problems in our urban areas is something called green infrastructure, and that's when we purposely build green or vegetated elements within the built environment. And so it can cool the urban heat effect to a certain degree. It can provide more building efficiency, heating and cooling if you do it as green roofs. There are innovative ways of doing it, and thinking holistically about how you work with urban planners, how you work with ecologists, how you work with hydrologists, and community leaders.
We should have trees along the facades of houses, which protect from the cold in winter, and which protect from the heat in summer. Architecture is evolving. The next stage will be to change the roofs of Paris, the zinc roofs. We'll have to change them one day or another. And change all these ideas about air conditioning, which is a mistake, and in my opinion, fatal for the planet, right? Because now we've come to consume more energy in the summer than in the winter in some regions. And make sure that people can protect themselves in housing that's cooled naturally. That can mean thick walls, small windows, small doors. It can mean a lot of things.
Many European cities are already taking steps against the effects of urban heat islands.
Barcelona today has 1.5 million trees and is continuing to plant new ones. Milan also has another program to plant 2 million trees by 2030. So this type of program can be found in many European cities.
Meanwhile, in the French countryside, the heat wave takes its toll on agriculture. The worsening drought conditions are devastating. The increased temperatures cause crops to dry out through evaporation. Farmers complain of drastic losses of livestock.
When the weather forecast predicts a heat wave, we as farmers, and I personally, have our backs to the wall. You never know how long it will last. We have huge yield losses. So I had friends who had chickens on the farm. There were more than 50% losses and deaths.
Countries across Europe face their worst harvests since the end of the Second World War. In Central and Eastern Europe, some governments have to import food for the first time in decades. The consequences of drought caused by the heat wave are felt throughout the environment.
Drought in our forested ecosystems due to the warming of the atmosphere, and that's because there's more evaporative demand, more water being basically sucked out of our vegetated systems. So these trees are becoming more stressed. They don't have as much water to keep them wet and moist, and so they're more combustible.
Extreme heat can create a natural disaster that threatens the lives of people all over the world, like wildfires.
Fires in the western part of the United States, for example, 8.4 million acres have burned. That's 2 million acres more than the 10-year average that we've seen in the landscape. We have 8 more fires that are 100,000 acres or more. What's 100,000 acres? That's about the city of Phoenix. As a scientist, I've been thinking about climate change. I've been thinking about how these forests are changing. We're losing words to describe it other than apocalyptic or horrific, because it's happening at a pace that we just never anticipated.
Higher temperatures, largely as a result of climate change, have dried vegetation that fuel wildfire. Meanwhile, the drying up of groundwater is accelerating combustion.
Take that combination of heat and drought, and you have the conditions necessary for the sorts of unprecedented bushfires in Australia, wildfires here in the western US that we've seen in recent summers. And so we can say with some degree of confidence that we would not be seeing these massive, faster spreading, hotter burning, more extensive wildfires around the planet were it not for the human impact on our climate, the warming and the drying caused by the increase in greenhouse gas concentrations from fossil fuel burning.
The danger of wildfires to the planet is not only due to burning forests. An increase in global temperatures is causing fire destruction in the most unlikely places with serious implications.
We can see where the increase in heat will create more forest fires, thanks to numerical modeling, and their impacts, whether it is in the northern boreal forests, meaning northern Canada, or Siberia. We saw huge fires in Siberia, and that was actually predicted.
We're seeing it in Arctic ecosystems, so we're seeing fires in tundra and tundra systems underlain by permafrost, and that is carbon that has been stored for millennia. This is old carbon, and the Arctic is like a refrigerator. It's been storing that carbon for us, and now we're getting fires into those systems. These are slow-moving fires. They smolder, they release a lot of carbon, and they move slowly across the landscape, and they move deeply into that old carbon, releasing a lot of carbon into the atmosphere. That was being our protection. It was being naturally sequestered, and now it's going into the atmosphere, causing more warming, which is causing more fires.
After a full week of the heatwave in France, the human toll begins to emerge. Reports touch on a range of potential vulnerabilities: short-staffed hospitals, an aging population, a government on vacation, shelters and parks closed. Health officials are clearly recognizing the threat, but no one seems to know when it would all end.
The end of the event was a little harder to forecast, so when it had been going on for more than 10 days, and we still saw that according to the scenarios it could still last several days longer, it was true that it was something that was hard to imagine, since the duration of the event was quite awful.
For more than a week, the temperature in France remains around 99 degrees Fahrenheit or 37 degrees Celsius. French officials know they are in the middle of the longest sequence of consecutive hot days in France's meteorological history. While attempting to dismiss its impact, some French officials instruct first responders on the front lines of the crisis not to issue any alarming messages or give out the number of deaths linked to the heatwave to the press. Authorities are unwilling to hold normal life or August vacations from proceeding unabated.
On the evening of the 12th of August, there were more deaths in Paris than there were ever during the Second World War. The mortuaries were full.
After nearly 2 weeks of extreme heat, Europeans finally get relief as the anticyclone moves and positions itself over the British Isles. Slightly cooler air reaches France from Iceland, and temperatures drop by 4 degrees. It would not be until early September that temperatures would drop another 12 degrees, signaling the end to this historic heatwave in France.
The 2003 heatwave finally broke after August 15th. As the air mass became a little more unstable and a number of thunderstorms began to develop.
The period of extreme heat is thought to be the warmest in 500 years. Temperatures regularly reach above 40 degrees Celsius across the continent over a period of 30 days. The heatwave's death toll is unprecedented. Heat stroke and dehydration claim the lives of mostly elderly people.
2003 was a huge shock. Afterwards, they had to count the dead, so they came up with a figure to say roughly the heat wave caused 15,000 deaths. In fact, years later, there were researchers who looked at all the statistics, and the heat wave caused a total of 20,000 deaths in France. It didn't only affect France, it affected the whole of Europe. and it caused between more than 80,000 deaths, probably 100,000. In 2003, we realized that we were there. We'd passed the tipping point. The atmosphere was different. We were in the climate change era. The heat wave of 2003 would also be the first time that researchers highlighted the link between climate change and a particular event. It marked the beginning of what we would call attribution, and we would go on to explain that the 2003 event was made more intense by climate change.
Heat waves are increasing in France, Europe, and everywhere in the world. It's a trend that appears to be getting more normal as the planet grows warmer and the climate changes.
We're talking about the release of fossil fuels primarily into the atmosphere, and then it becomes just chemistry in the atmosphere in which that carbon dioxide is basically re-radiating heat back into our environment, causing it to warm.
After the 2003 heat wave, climate researchers studied the link between climate change and the 2003 heat wave event. What they found was that global warming, the fact that the atmosphere was richer in CO2 due to human activity, had caused temperatures to rise by 1 to 2 degrees in this event, compared to what they would have been in the pre-industrial era. So in a way, the extreme temperatures observed in 2003 were already the consequences of human activities and climate change.
I think it can be said that the heat wave of 2003 was a brutal wake-up call to climate change. We talk a lot about climate change as something that is going to happen in 2100, so it seems very far away. It also seems very far away because we talk a lot about it on a global scale.
In sort of a worst-case scenario where we fail to reduce carbon emissions and we raise carbon dioxide concentrations to more than 3 times the pre-industrial level by the end of this century, and basically a third of the planet becomes unlivably hot. Heat indices that exceed 130 degrees Fahrenheit. Basically the entire tropics become unlivable. You can understand the immense conflict that will arise, and the sort of potential societal instability that will arise. We're already seeing some of that in the form of environmental refugeeism, climate refugeeism. And that's why climate change literally does pose a threat to human civilization. Reached a point now where we're actually seeing the impacts of climate change play out in real time in the form of unprecedented extreme weather events.
C'est pas la première catastrophe.
This was not the first disaster in France, but was the first disaster due to global warming with social, political, health, environmental, and organizational consequences, and was still paying for the consequences, in fact.
Sanitaire, environnemental, organisationnel, et on est encore en train d'en payer les conséquences. Et il va y en avoir de
There are going to be more and more of them with consequences due to global warming, changes in vegetation, changes in food, the problem of access to water. It is said that the next wars will be fought over the availability of water.
Today, variations in the Earth's climate have exceeded predictions made decades ago using climate models. With the collapse of ice sheets in Greenland and Antarctica, the North and South poles are warming faster than the tropics. As a result, the jet stream, the meandering air current primarily responsible for heat waves, is changing.
So here in the Northern Hemisphere in the summer, we have seen these very unusual weather systems that just linger. They stay in the same place for days at end. A slower jet stream, a more wiggly jet stream that gives us larger weather anomalies. So we get these very deep, high-pressure systems leading to these more persistent weather patterns here in the middle latitudes, including these heat waves that we've seen in recent summers.
Some scientists now predict that in less than 20 years, millions of people in the US could be exposed to dangerous heat conditions of up to 127 degrees Fahrenheit. But heat waves will be most severe in the already hot tropics, in countries from Bangladesh to Sudan, where people may struggle to afford adequate cooling. Large parts of the world, from the Middle East to Siberia and Australia, have seen fast worsening heat waves in recent years.
A study by the World Health Organization says they calculate an increased impact per year of 250,000 people. So, 250,000 people per year exposed to the risk of heat waves. If we make the hypothesis that it continues at this rate, which is probably a little uncertain, we can assume that in 30 or 40 years, we'll arrive at figures of around 2 or 3 billion more people exposed. However, the climatic future of France, Europe, or the planet after 2050 is not set in stone. So the efforts we are making now can enable us to avoid having these mega heat waves that climate projections are forecasting.
I think that we can see climate change as an opportunity, because in fact it is a change that is here anyway, and which demands that we ask ourselves questions about the way our society is organized, both locally, regionally, and internationally. We have to find ways of adapting that suit us in relation to our values, and use climate change as a crucible to rethink our values.
An effort to limit the number of heat waves and their effects is one of the goals of the Paris Agreement signed by 197 countries in 2015.
The Paris Climate Accord was a critical development. It really committed all of the nations of the world to meaningful reductions in carbon emissions. It won't solve the problem on its own. It gets us maybe about halfway there. Under a Biden administration, we will see the United States re-engage with our global partners. And that means reducing our own carbon emissions, putting in place policies to incentivize renewable energy, to put a price on carbon to reduce carbon emissions. Then there is a path forward where we keep warming below that dangerous 1.5 degrees Celsius, 3 degree Fahrenheit warming level. So that's the good news. We still have time.
It is imperative today to follow the Paris agreements. We cannot think about adaptation without also thinking about this other lever that is mitigation.
Our findings indicate that we do need to change our way of doing things. We need to get away from the burning of fossil fuels. There was now a detectable impact of climate change, and subsequently we've seen the damaging impacts of climate change, and we've been communicating this to the public and policymakers only to be attacked by vested interests and politicians working for them who find the science inconvenient. We've seen the same thing play out on a much more rapid timescale when it comes to the science of coronavirus, of COVID-19. We've seen how deadly that is. That toll has taken hundreds of thousands of human lives here in the United States. And so we have seen in real time how deadly that sort of anti-science can be. Here with climate change, we're dealing with an even greater crisis. We will get past coronavirus. We will get past the pandemic. But still looming in the background will be the existential threat of climate change.
Since 2003, weather models have, of course, made great progress. They have made enormous progress in terms of spatial resolution. And so today, compared to 2003, we're able to predict temperatures more accurately and perhaps better in terms of the exact location of the temperatures. We can also better anticipate phenomena several days in advance.
Extreme heat is already transforming our world. Disney executives recently voiced concern that rising temperatures will significantly reduce the number of visits to their parks. In Germany, officials were forced to put a speed limit on the Autobahn because of fears the road would buckle from heat. Researchers suggest that rising temperatures and humidity may make much of South Asia, including parts of India and Pakistan, too hot for human existence by the end of the century.
We have smart people working on the technology side. I think people just need to be incentivized. And I think once the politics falls in line there, I think we can move towards a brighter future.
I'm going to try to adapt my crops. In fact, it is genetic research that is changing with the wheat varieties. Some are more resistant to heat, others more resistant to humidity. So we really have varieties that manage to withstand, all the same, notably slightly longer dry periods than a few years ago.
vu qu'il y en a de plus en plus, on peut se dire que
Since there are more and more heat waves, we can say that our genetic defense against hypothermia is gradually being built up, and we are beginning to get a little more used to it. But if we reach extreme heat levels, you can imagine 55 degrees in Paris, there will be consequences. There will be dramatic consequences.
To protect lives in the face of the increasing threat of heat waves, there needs to be long-term planning.
Urban planning must take many, many things into account, speaking only of climate. For example, the size of the city, and therefore transport to work, to access services, etc., have a huge impact on health and on climate too. The type of energy that has to be used for a spread out city or for a city that is extended more vertically is totally different for heating, for food. And so all these things have to be taken into account, and climate is the new order.
The Austrian capital Vienna has created a network of car-free Coolstraßen, or cool streets, that ban cars in certain neighborhoods and offer outdoor seating areas and cooling mist sprays which can lower ambient temperatures by several degrees.
The city of Paris has brought out an application called Extrema, aimed to provide information notably on what a heat wave is, the impact that it can have in terms of health, and how to protect yourself in your home, in your daily activity. But this application also allowed you to locate cool places within Paris. There are different topologies of cool places that were proposed, so it was the air-conditioned places. For example, swimming pools, parks and gardens. These different places were listed where you could go to be in a cooler place. There are a number of works that have allowed us to experiment with cooling furniture. We found some in Paris, but there are also experiments with cooling materials that use the evaporation power of water in the same way. We have seen examples in Nice with evaporative paving stones that were tested to see just how much the temperature dropped and whether this also had an impact on users.
In Nice, France, water plays a key part in keeping people cool. There are many fountains, lakes and rivers, not to mention the sea. But now they are also using pavement wetting systems, operating as a spray system, but also as a series of porous paving slabs that soak up water from their underside. They are designed to literally take the heat out of the city.
The evaporative cladding that was tested in Nice. Typically, there is a system of water networks under the paving stones that, according to the climatic conditions, will or will not start working, and thus will, by capillarity, make the water go up in the paving stones, so we don't have a puddle, finally, on the surface. It is really by capillarity that it works, and in fact, with the temperature, the heat outside, it produces evaporation, and thus it participates in the decrease of the temperature.
By stabilizing global carbon emissions in the next few decades, the frequency of heat waves in the United States could be reduced by approximately 50%.
Climate change mitigation is critical to us making any dent in towards saving our ecosystems. We really need to move towards a renewable economy so that carbon dioxide is not baked into our forest futures, not baked into the ecosystems of our children and grandchildren, moving to systems that we have never experienced in all of humanity. There will be winners and losers in that new world, but unfortunately I think it's the poor and the vulnerable who will not do as well as some of the others.
As of now, we get about 23% of our total power consumptions from renewable resources, and India has embarked upon a very ambitious program, the largest of its kind in the world, of generating 175 gigawatts of energy through renewable resources, primarily through wind and through solar areas. And also, gradually the electrical and solar powered vehicles are being introduced, and the government has planned to gradually increase their numbers over a period of time. India has a target of having 10 billion square feet of green building area by the year 2022.
What's the solution to this problem? Is it individual behavioral change, changing our behavior to reduce our carbon footprint? But individual action alone isn't going to get us the reductions in carbon emissions that we need to avert catastrophic warming. So in addition, we have to engage in collective action, people working together to change the system. That can take the form, for example, of voting and putting pressure on our policymakers to support policies that will price emissions out of the market, that will provide incentives for renewable energy to replace carbon-based energy. We can't create policies, but our policymakers can, and we need to hold them accountable. They need to be accountable for our interests rather than the polluting interests who too often fund their campaigns and to whom they are too often beholden.
It is really hard being an earth scientist right now. There is a lot out there to be worried about. There is a lot of signs of the apocalypse, truthfully, but we also see this beauty that we haven't yet discovered as a scientist.
In fact, climate change is a huge driver of change. Now, the question is, do we want to suffer this change, or do we want to choose this change?
The deadly 2003 heatwave that struck France was a prophetic indicator of a warming planet that has since only gotten warmer. But heatwaves can also be an awakening for government leaders, industry executives, and even science deniers to take action now to save their children's future and the destiny of planet Earth before it's too late. It causes crops to fail. Grazing land to dry up. Forests to catch fire. Drinking water to run short. And entire empires to fall. This is drought. Droughts have changed the course of human history. More than 75,000 years ago, a series of mega-droughts may have been responsible for the first migrations of early humans out of Africa. In the Bible, drought was thought to be responsible for driving the Israelites into Egypt. In the last century, drought caused a dust bowl across the Great Plains of the United States, sending 2 million people off their land. In China, the drought of 1928 claimed somewhere between 3 and 10 million lives.
Today, throughout the world, you have extremely high areas of tension related to water. And we can see very clearly that the fact water is listed on the stock market is a real question that alarms us. Will this help us to understand water importance and protect it? Or is it going to become a tension again? Because there's a monetary dimension behind it. The future will tell us.
In this century, droughts have a role in reshaping the world by limiting access to fundamental resources, forcing populations in Africa, the Middle East, and Central America to migrate to find sustenance.
What we're looking at is dramatic. It's in nobody's interest to have the entire system collapse, and it could definitely happen, and it is absolutely a looming disaster, and it's just a matter of how we're going to get ourselves out of it.
If we don't take into consideration all the problems that are generated around drought, we have to imagine that it's us directly who will pay for all that we've generated. So whether you're a big industrialist, a farmer, or an ordinary individual, at a given moment, we're all citizens, and we will all be confronted with this problem.
How dangerous are droughts? And what, if anything, can we do to stop them? On America's west coast, the state of California is no stranger to the scourge of a drought.
The first time I became aware of drought in California, when I was governor the first time, 1977. And that was a serious drought that affected the state north and south. So that was really the first time I thought about it.
State and federal water agencies started to plan for the worst. Another dry year. On March 4th, 1977, Governor Brown, by executive order, established a drought emergency task force.
But nothing quite prepared Jerry Brown for what was to come 34 years later. He would face drought again as the re-elected governor of California. Only this time, it would be the most intense, dry period in the state's history. One that would stretch on for 6 whole years. In 2011, the seeds for this historic drought are sown hundreds of miles away in the cooling waters of the Pacific Ocean near the equator. It's called La Niña, a weather pattern that tends to shift the jet stream, the meandering westerly air current encircling the globe. This shift leads to colder weather in the north and warmer and drier weather in the western United States.
So when you have a La Niña year, it tends to mean dry winters, but it doesn't give you much like granular predictiveness. So we know it'll probably be dry this year, but that doesn't tell us how dry, or it doesn't suggest that it won't rain at all.
The La Niña for 2011 is among the strongest ever recorded. The jet stream shifts and a stubborn ridge of high atmospheric pressure moves over California. Storms are pushed to the north. The Great California Drought has begun. Over in Europe, the effects of drought were already being felt in France, where the rainfall was dramatically below average for the year. According to Météo France, the French government weather agency, the country had not experienced this severe a drought in 50 years, but the warning signs were there.
You would be walking in July or August in the forest, and there was a carpet of leaves already on the ground, the carpet of dry leaves that you usually see in the autumn. It's an advanced phenomenon, with sap that doesn't reach the leaf, and then the leaf slowly dries out.
It may take weeks or months to perceive that a drought has even started, or when it's over.
We have, other weather phenomena that are hazardous to humans, like tornadoes, where they're difficult to predict in the moment, but you can see the weather system forming. You have some sense that it's going to happen. So drought isn't like that.
The immediate effects of a drought may be difficult to identify at first.
A drought is essentially insufficient water to meet needs. It doesn't tell you whose needs, or it doesn't tell you what insufficient means. The problem with defining drought is that it depends. So it depends on who you are, what you care about. It depends on the scale, the time scale. So is it a shortage of a couple of months a season, or is it multiple years of drought? Obviously that changes who cares and how they're impacted.
There are three types of drought. The first type is a drought which is called meteorological or atmospheric drought. That is to say that we'll have an extremely important rainfall deficit. So the deficit will come from the sky. The second type of drought is really a type of drought that we call agricultural and is a drought that will only affect the soil. And finally, the third type of drought that we find is what we call hydrological drought, which is a drought that will affect either the rivers or the water tables.
A water table is going to be filled by rain and by watercourses. A water table that is very deep can be recharged in thousands of years. In France, considering that 50% of groundwater is used for drinking water, 25% for agriculture, and about 25% for industry, completely emptying a water table will limit us in the use of groundwater, knowing that the absolute priority is drinking water. Human activity has a strong impact on water tables. Here, we are in the inner suburbs of Paris. So there is an enormous amount of human activity.
In France, a measurement to assess the probability of future drought is the water table. Drilling down into an aquifer to measure groundwater is the responsibility of the Bureau of Geological and Mining Research.
There is a piezometric probe. When the probe comes into contact with water, current can pass through two small electrodes and it beeps. When it beeps, I'll look at how deep we are so I have the depth of water.
The goal is to provide a forecast on drought based on the state of the water reserves in France and to make wiser decisions over its use.
If the water table is at a critical level, it allows me to trigger measures in relation to uses, be they uses for drinking water, for watering, for irrigation, and of course for industry.
In the summer of 2011, more than 68% of the country's underground water reserves were well below average. The situation led authorities to restrict the use of water, including irrigation for agriculture.
There is a major health risk if there's no more drinking water supply at a satisfactory level. In France, in some towns, we're now bringing tankers, but we're not in a situation where it's a major health issue yet.
The rains eventually return, ending the historical drought. A water crisis in France is averted until the next time.
We tend to forget about it from the autumn onwards. As soon as we go into a situation with more or less normal rainfall, we tend to forget what we've experienced.
But for California, normal rainfall is still nowhere in the forecast. 2 winters have since passed with well below averages. New Year's Eve in Los Angeles ends 2013 as the driest ever on record.
As governor, each year, we get weather reports, and some are more rainy, some are hotter, whatever. But right there, 2012, 2013, we started to notice drought conditions.
Among the state's biggest concerns, will there be enough drinking water for California's 38 million residents in the near future? Because the air is warmer, the snowpack, a vital resource for water, is shrinking. High in the Sierra Mountains, the snowpack melts during the hot summer months. It refills California's reservoirs, providing much of the state's water supply.
They tell me Shasta Dam is nowhere near at the level we're going to need. Not at capacity, and not even half full. And other dams, we're told. So we get the reports. The snow is not there. The dams aren't filling up. The rivers are down.
Measuring the snowpack's water content is crucial in planning for drought. Yet much of the snowpack is remote and out of reach by surveyors. To better gauge the amount of water that will flow, NASA, the United States government's Aeronautics and Space Agency, created the Airborne Snow Observatory. Flying 20,000 feet over the Sierra mountain range, researchers use airborne lasers and radar to measure the snowpack on a scale and elevation impossible to reach by foot.
Understanding the snowpack is really, really important. How fast does it melt? Where does it melt? How is it accumulated? And until this project, we really have not had spatially complete information. We've had very patchy information. We can add up how much water there is in the mountain snowpack in the entire basin.
Today, scientists can calculate water content to within 5%. Researchers believe the technology could someday be used to examine changing snowpacks worldwide and to measure the effects of global warming. In 2014, the Sierra snowpack measured just 32% of average for this time of year, one of the lowest measurements on record.
The forecast doesn't look that great for January, so I would say I became aware, like we always become aware, as the winter is upon us, where the hell's the rain? And in that 2012, 2013, 2014, it got serious, and we knew very well we were in for it.
It's important to awaken all Californians to the serious matter of drought and the lack of rain. We are in a unprecedented, very serious situation, and people should pause and reflect on how dependent we are on the rain, on nature, and one another. And I'm calling for a collaborative effort to restrain our water use. Today, I'm declaring a drought emergency in the state of California.
For Governor Brown and the state of California, the crisis is just beginning. In 2014, facing the driest year ever recorded in the history of California, Governor Jerry Brown declared a state of emergency. The order allows him to call up the National Guard to deliver water. He asks communities to voluntarily reduce water use by 20%.
The people who use most of the water are the farmers. Okay, they're using 80% at least. And if the governor has to tell them, you're not going to get that water, then they really lose. That becomes a crisis. So it became, as we make the choices, to ask the urban people to conserve. If they conserved enough, then we could keep our agricultural economy strong.
Water agencies begin public awareness campaigns to get Californians to change their habits.
Sometimes it seems she's all alone in this drought. Of how serious things are. We can't waste another minute wasting water. It's time to conserve even more.
Does everybody pull together? No. In the effort to get people to conserve, when it was voluntary, which it was for the first couple of years, there was some conservation, but not enough.
Drought doesn't quite get the respect it deserves because its impact evolves slowly. Most of us are unaware when we are in one.
You may not even realize you're living in a place that has dry conditions. People who live in cities may not actually experience drought directly. Contrast that with somebody who lives in a place, or has a livelihood or lives in a place that's directly dependent on precipitation.
You know, right here, where I am now on my ranch, this is where my grandmother was born and grew up, so we have a lot of history here. I know that we've only had 2 inches of rain because it doesn't come very often, and a few years ago we had massive rains. So it's something that I experience, I can see. But when you're in the governor's office and you're in the normal urban environment, it's not so noticeable. We are in a somewhat plastic and mechanical bubble where the conveniences of modern society are made available. But we put our periscope up and we get the data, and the data look really bad.
The crisis draws national attention. Bringing relief from the federal government, President Barack Obama visits the state and the Central Valley. It is here where over 1/3 of the nation's fruits and vegetables are grown.
As anybody in this state could tell you, California is living through some of its driest years in a century. California is our biggest economy. California is our biggest agricultural producer. So what happens here matters to every working American, right down to the cost of food that you put on your table.
The president came to provide money and provide help and to listen. He listened to the farmers, some of the farmers who were most at risk and were hurting.
The impact of drought on agriculture has consequences for both biological and economic survival.
In some places around the world, you know, a drought is literally a threat against food security and water security. You don't have enough food, you don't have enough water because it didn't rain.
Droughts have always been responsible for major conflicts, wars, and famines. When you go back in history, most of the great wars and revolutions and revolts were generally linked to periods of famine, which were linked to series of droughts. Indeed, when we look at the French Revolution, one of the indicators that tipped the system over is the price of bread. So we can see that there's an immediate and direct link between these popular revolts and this climatic impact that will affect the harvests of our territories.
One of the worst droughts of the last 300 years was the Dust Bowl. At its peak in 1934, the extreme drought covered 75% of the United States. It lasted nearly a dozen years amid the Great Depression. Millions resettled to the western United States. Today, drought continues to force mass migrations from Central America, Africa, and the Middle East. But now, scientists are researching ways to reduce the destructive social impact of the changing climate that is already evident around the world. NOAA, the National Oceanic and Atmospheric Administration of the United States, funded a project designed to more accurately monitor and plan for drought across the 2,500 square mile Hopi Reservation. Since 500 BC, the Hopi Nation has lived in northern Arizona, an area of the American Southwest known as Four Corners.
The Four Corners of the U.S. Southwest is a magical landscape. So it's Four Corners because there's 4 states that come together: Utah, Colorado, New Mexico, and Arizona. It doesn't get a lot of rain, so there's a lot of exposed rock. It's just a stunning landscape. It's iconic. It's where the Grand Canyon is. So the Hopi agricultural and cultural systems more broadly are actually really well adapted to dry conditions because they've essentially always lived in a dry place. And they have very, very elaborate strategies for growing corn in a dry place without irrigating.
We used to get our water over here just to drink. I mean, it was so good. Once you had a taste of it, you couldn't stop. You wanted more. One of the things that really connects us is the water. It gives us hope. It gives us inspiration. But now everything's drying up.
As the climate changes, with more severe drought conditions, the traditional Hopi way of life is under threat.
One of the many challenges with confronting drought, essentially, in the Four Corners is that it's a very large landscape, but there's only effectively a small handful of weather stations that report on the conditions on the ground in that place. The people charged with that task of putting out stations, maintaining them, and making sure the data comes in and it's of high quality have never really quite figured out how to work with indigenous communities. So they essentially don't have access to the data that they need to understand how their landscapes are being impacted by drought.
A team from the Hopi tribe and the University of Arizona conducted research across hundreds of miles of reservation land, assessing range conditions, checking in with ranchers and farmers.
So we dove in and figured we could help with this question about monitoring for drought on the Hopi tribes' lands. And we did wind up helping try to figure out a way that they could do monitoring of their landscape, sort of qualitatively for drought.
The team tracked wildlife, monitored soil and wind erosion, dried up springs, declining grazing land, and failed harvests.
We really got to understand a problem in the context of a community who was wrestling with it. Many of the colleagues that we worked with really came to recognize the importance of and the challenge of, this direct engagement strategy that we have.
The project provided Hopi tribal leaders with more information on when to irrigate, close grazing lands, plant crops, or haul water. Monitoring detailed climate conditions enables more informed decision-making by farmers and water resource managers in communities around the world, vulnerable to drought. As the historic California drought continues, the state is not meeting its goal of a 20% reduction in water use. Governor Jerry Brown travels into the mountains to inspect the snowpack and is alarmed by what he sees.
I decided to go up to the Sierras near just west of Lake Tahoe, where normally they put a pole in the snow. They say, oh, we got 10 feet of snow, 15 feet. Well, this was the time, for the first time, I don't know forever, but in my living memory, there was no snow at all. So that was the new abnormal, and there it was for all to see.
This is the first year in its measurements going back to 1942 where this snow course has been bare, no snow at all.
The Sierra Snowpack's annual average water content is 28 inches. In 2015, it measures just 5% of normal.
We're in an historic drought, and that demands unprecedented action. It's for that reason that I'm issuing an executive order mandating substantial water reduction across our state. If everybody in California did the maximum in water conservation, we wouldn't need a mandatory. But because different groups, different cities, different water districts, different individuals do different things, we do have to make it mandatory. So as things got worse, we had to go to mandatory.
The governor imposes a 25% reduction to state water agencies, which supply more than 34 million Californians and nearly 1 million acres of irrigated farmland. It's unprecedented. The state of California has never seen anything like it before. Life in the Golden State is about to change. Over the years, California has developed an elaborate water infrastructure system. It's an impressive display of reservoirs and aqueducts built throughout the state to quench the thirst of its residents. Water is not only a precious resource for California's farmers, it is central to the state's identity and economy. It sustains the golf courses in the deserts of Palm Springs and lush gardens and lawns in the metropolis of Los Angeles. Lawns consume much of the water used every year in California. Brown's executive order calls for the state and local governments to replace 50 million square feet of lawns with native plants and drought-resistant ground cover.
And for hundreds of thousands of people, yes, they're putting in rock garden or drought-resistant plants. Everything we think about is oriented now to drought and what that means to our lives.
In 2015, the fourth year of drought, casualties to California's ecosystems appear.
There were a lot of impacts, but more importantly, it's on the environment. The algae that grows in the rivers and the lakes, that begins to bring diseases for the fish, for the animals, for the birds. The experts are seeing the degrading of our natural environment and habitat, and that only gets worse as these drought conditions continue.
There is one of the users of water that we must absolutely not forget, because otherwise we'll be the ones who will lead our own loss. It is the natural environment itself. If we don't leave water for this natural environment to allow it to renew itself, in fact we're the ones who pay the direct consequences behind these effects of biodiversity loss.
Some of the first casualties are native fish populations. When streams and rivers are so low, fish cannot get to their spawning grounds. One of the most devastating environmental consequences of drought is the impact on forests.
Drought really has a direct and biological impact on the trees. When you have a completely dry spring and/or summer without water, with a heat wave, the trees no longer have the root system necessary for them to feed and hydrate themselves, and so the trees die. And this phenomenon has really become more pronounced in 4 years.
Dried out trees that die are potentially explosive, becoming fuel to spread a wildfire. In California, wildfires in 2015 consume over 900,000 acres. A recent study conducted by the United States Forest Service predicts that the number of acres susceptible to fires could double by 2050.
Just like the big fires that we've experienced in California, we can imagine that the Mediterranean area will evolve and experience bigger fires. Fires that may no longer be controllable. Even if France is recognized for its ability to manage large fires with its fire brigade reinforcements.
Firefighters in France have a new weapon against the spreading flames. Using drones in remote, inaccessible areas, firefighters are able to identify potential fires and instantly transmit exact coordinates for ground response teams.
Drone and satellite imagery is increasingly powerful and gives us immediate indicators that allow us to know whether the level of risk is high or not. The thermal imaging camera enables them to see the hot spots on a fire. When a fire is extinguished and dewatered, there are still hot spots, and there can be resumption points in the forest simply because the forest floor is rich in leaves, rich in decomposing wood.
With eyes in the sky, firefighters have an advantage in what is often a race against time. As lakes and streams are reduced, California utilities have less reliable hydropower to supply the electric grid. Power outages are not unusual.
Just picking up some last-minute water supplies because I realized the implications of the power being off. Just heard that actually tap water may be off when the power goes off. So I want to prepare. Just we don't know how many days it's going to be. So
when land lacks water, it contracts, resulting in uneven and dangerous roadways. The shift in the earth also affects the foundations of houses and buildings.
In fact, the impact of droughts on infrastructure and buildings is mainly due to a hazard known as clay shrinkage and swelling hazard. In fact, 1/5 of France is concerned by this type of hazard. As you have new rains, the soils are going to swell. These clay soils are finally going to rehydrate themselves and are going to make soils move. You'll see cracks, then you may find yourself with a door or window that no longer closes. You'll have cracked walls, and if the effect goes much further, and we alternate with more rain and more drought, then we'll end up with walls that will completely collapse.
The reduction of fresh water causes social impacts that are less obvious. Job loss, declines in community mental health, and threats to public health are due to low water levels.
So the hazard can be like the broad-scale human disaster of lack of food, famine, and lack of water. But it can also be simply, really pressuring the economics of a region. Livestock growers don't irrigate for their forage for their cattle or sheep. So if it doesn't rain, they don't really have food for their cattle, and that impacts them directly economically.
Droughts can last weeks, months, or years. The state of Arizona has been in what scientists are calling a megadrought, which can last for several decades.
So the challenge with drought, really, predicting drought, is it's a very, very complex system. And even with really sophisticated weather and climate models, it's difficult to put any kind of precision on a forecast for drought.
But clues may be found in the rings of ancient trees. Tree rings from these giant sequoias are windows into California's history, going back 1,000 years. Good years are reflected in wide growth rings, while narrow rings mark lean and dry years. Clusters of narrow rings show prolonged, devastating periods of drought. Here, carved in wood, is the evidence of the changing climate of the distant past.
We know from examination of tree rings and other observations that there were 100-year droughts in the Middle Ages in California. So we had some rain a few years ago. We may be in a longer-term drought, maybe last 10 years, 20 years, who knows how long.
Wide rings are the record for boom times, when the environment was good and cultures flourished. Narrow rings reflect when the climate went bad. Hard times set in, along with societal conflict. In the state of Texas, new tree ring studies indicate the land experienced at least one 10-year drought every century. Tree rings in Mexico revealed the collapse of great indigenous civilizations, like the Aztec and Toltec empires. Will the rings of California's future be narrow or wide? Is the American Southwest heading into a decades-long mega-drought? It is 1 year after Governor Jerry Brown called for mandatory water reduction. About 1,900 wells have gone dry in the state, leaving people in some of California's most disadvantaged communities without water. Across the state, the drought has raised food prices. Some local city officials call for drastic measures, like banning all outdoor landscape watering and ending construction permits for swimming pools. But most urban residents respond by cutting water use by nearly 24%, exceeding the state's goals. To help reduce use, thousands of homeowners claim rebates to rip out their green lawns and replace them with drought-tolerant landscaping.
The notion of every house with a green lawn, that has been challenged, and for hundreds of thousands of people, yes, they're putting in rock garden or drought-resistant plants. Everything we think about is oriented now to drought and what that means to our lives.
By 2017, a reprieve comes from the skies. The jet stream has dipped south, bringing with it rain-soaked storms for the entire West Coast. In February, California water managers returned to the Sierra Nevada snowpack to measure water levels.
Very significant increase in snow water content throughout the state, with the central and southern regions showing almost phenomenal increases in snow water content.
It is the most snow recorded since 1995. The storms brought 3/4 of the state's normal yearly precipitation in just a few weeks. On April 7, Governor Jerry Brown declares the drought over and lifts the emergency order in place since 2014. By mid-March 2019, most of California is declared totally drought-free. While Californians survived the drought, nearly 150 million trees perished from dehydration.
What comes out of this drought is certainly the experience of people working together, experiencing their membership in a community, in a neighborhood, as people of California. So we do heighten our awareness when these challenges occur. I mean, the same thing happens in a war. People do pull together and sense their identity because there's a common adversary. Well, a drought becomes a common adversary, or a forest fire, or in a more general way, climate change.
A new NASA study predicts that by the end of the 21st century, the American Southwest and Great Plains are likely to experience longer and more severe droughts than at any other time in the last 1,000 years.
So recent droughts, such as the ongoing drought in California or in the Southwest, or even historical droughts such as the Dust Bowl in the 1930s, these are naturally occurring droughts that typically last several years or sometimes almost a decade. In our projections, what we're seeing is that with climate change, many of these types of droughts will likely last for 20, 30, sometimes even 40 years.
California, for 15,000 years, never had more than 300,000 people. Now, we have 40 million, and we haven't had that many that long. And it's a lot of people, and most of them have a car, and most of them burn a lot of oil, or gas, or diesel. So we're impacting our environment. Then, because the climate is warming, and we're getting the traditional droughts that come and go, all that combines to devastate our natural environment. The world is changing, and it's changing subtly.
Warmer temperatures brought on by greenhouse gases are changing the climate. It appears some droughts no longer dissipate as quickly.
So, the impacts of climate change on groundwater resources have been modeled by scientific groups. And it is estimated that, according to these models, groundwater recharge deficits would be of the order of 10% to 20%, which will inevitably lead to a drop in groundwater levels, which will lead us to modify and adapt to our uses.
Since 2017, not a year goes by without a historic drought. So we are beginning to feel, I would like to say from our chair, hydrologists, this climate change because the weather is getting too hot. We can see very well that we have totally abnormal temperatures in France with effects that are abnormal. Any climate disruption is a disaster for an ecosystem, one way or the other. There may not be any heat wave next year, but we'll have them more often, and it's the risk that will be there. And unfortunately, it's taking place more often.
According to a United Nations Water Development Report, water use has increased six-fold over the past century and is rising about 1% a year. Poor water management tends to exacerbate the impacts of climate change, not only on water resources, but also on society as a whole.
It's very complex today to have a very clear idea of what a 2 to 4 degrees scenario will be like in our territory. It's all the more complex because these are elements and data that the population isn't familiar with. We'll have to try to regain coherence and rethink how we're going to be able to build France's resilience in the face of these extremes. And I'm sure that we can achieve this if we try, in a consensual manner, to all move in the same direction. It's our behaviour today that will have an impact tomorrow. The real problem today is our capacity to adapt and the speed with which we will succeed in adapting.
America faces tremendous challenges with the automobiles, the trucks, the trains, the factories, burning all this oil and gas and coal to get off that and to get to zero carbon emissions or a net zero. Wow, that's like climbing Mount Everest, and we got to get at it right away. So there's much to be done. There's massive political resistance.
The denial of climate change as a real problem is intentional. The reality, though, is that at this point, so many communities are experiencing the impacts of drought, climate change, that there's a limit to how, I hope, to how long people will deny what's directly in front of their faces.
Look, it's very simple. If climate is changing, then we have to change. And in order for us to change, government is going to have to play a very powerful role. Otherwise, it can't happen. Government by way of carbon taxes, government by way of regulation, by way of banning oil and gasoline cars, by making buildings more efficient, by making appliances more efficient, by all sorts of things.
But you also have a much more coherent push towards collaboration with the scientific community, trying to figure out how to do a long-range drought plan.
Drought plans not only benefit from scientific research, but also by the experience of the community. It begins by recognizing who the victims of drought are.
We have what we call, well, what I call it, transparent disaster victims. Because when you're affected by a drought, in fact, you don't immediately recognize a natural disaster. It will take several months before you're recognized as a victim. When you're flooded, you're recognized somehow. You have media that come to cover the event and consequently recognize you as a victim. Drought has victims who are in silence, who you don't see, who are nevertheless there. And this is something that we will really have to take into consideration in the coming years.
Et c'est quelque chose qu'il va vraiment falloir prendre en considération dans les prochaines années.
To be better prepared for the drought that lies ahead, decision makers in business and public service will rely on accurate climate information.
When we imagine that by 2050, we'll have a world population of around 8 to 10 billion people, we'll have to bring water to these people, sometimes in areas where there is none. And secondly, we'll have to feed them. And to be able to feed people, the food system itself needs water. Without water, we have no food. And for me, this really is the biggest crisis to come as far as water is concerned.
There are some people who say that the next war will be the water war. Well, war, perhaps not with weapons, etc., but in any case, there are wars of territory, wars of influence.
I remain optimistic because I'm aware of a number of solutions that can be implemented. Today, there are innovative solutions that allow us to put materials in the soil and capture water. We're going to have to train our populations to know that we save water when we turn off the tap, but also we save a lot of water when we change our eating habits. An average French person does not consume between 250 and 350 litres of water. He or she consumes between 5,000 and 7,000 litres of water from what he or she eats. That is to say that from his or her virtual water that we don't see, which nevertheless allows us to make our food, our clothes, and everything that makes up our daily life.
In addition to minimizing greenhouse gases, new scientific research is dedicated to improving water desalination plants, cloud seeding to make artificial rain, and recycling methods to convert wastewater into drinking water. Developing drought and heat stress-resistant crops will improve the ability of farmers to cope with increasing frequencies of temperature and the scarcity of precipitation.
We'll have to rely on either solutions based on innovation or on common sense. And indeed, agroforestry, for example, allows us to completely rethink the effects of shade, plant relationships, and the importance of planting trees.
NOAA's National Integrated Drought Information System is working to develop regional drought early warning information systems across the United States. It's an effort to unify the federal drought response in the US and throughout the world. In 2020, France experienced its worst drought since 1959. By midsummer, there was only 16 millimeters of rainfall nationwide. Rivers, basins, and lakes were abnormally low. 25% of France became dry. Groundwater and river flows decreased.
In France and in Europe, for like 20 years now, 25 years, there are water management systems that have been put in place and that lead us to really make the water table level rise. It's quite under control, and it's less worrying than if there were no such measures at all. If the water table drops critically, the state has set thresholds. These thresholds will trigger measures. In general, there are 3 thresholds. A first threshold, which will rather ask private individuals to stop watering, filling swimming pools, etc. A second threshold, which concerns irrigation, for example, to try to moderate all that has to do with watering. And a third threshold, where there is such a level of alert that we stop everything so as not to completely deplete the resource. Drinking water remains the #1 priority. So, as a last resort, generally speaking, we never stop drinking water. It is necessary to set up strategies which allow to protect the underground water and to recharge it. Collecting rainwater and bringing this rainwater to infiltrate in an artificially active way to recharge targeted aquifers that have a particular use at stake elsewhere. In 2019, there were many drought decrees that were taken in many departments of central France, which led all the users of these sectors, for some, to stop their activities completely or drastically reduce their use of groundwater.
By now, most inhabitants on planet Earth are witnessing a changing climate, spawning unprecedented extreme climatic events.
Can human beings in India and China and America and Mexico and Brazil, can we respond in time? We can, and we must, we should. Science is telling us, with accumulation of data and theoretical conclusions, that we have to innovate, we have to change our ways.
Planning the right response to future droughts is becoming increasingly vital.
I believe very much in the fact that we will have to put consciousness at all levels, put consciousness in our big companies. If they put in the right level of awareness and they're sincere in their commitment, I'm sure that we can do very beautiful things and that nature can at some point be reborn and restructure itself because it has much faster capacities than we do.
Drought tends to give us a greater awareness of our citizenship to a larger community and how truly vulnerable we really are.
What is at stake here is what I would call planetary realism. For the first time, wherever you live, you are clearly implicated in where other people live, and we're all affected together because of the climate, because of the changes, and we are tied together in the human family in a way that may be perceived by poets in the past, but increasingly will be perceived by all the people.